All right, ladies and gents, what's up? Again, as I told you, I would create a video to quickly review what we learned today, as well as going over one of the examples so that you know what to do for your asynchronous assignment. All right. Again, if you have any questions, comments, or concerns, you can always reach out to me via email or Google chat me. I'd be more than happy to help. So what we learned in class is the following. Multiplicities tell you what happens around the x-intercepts. If the multiplicity is even, it bounces. If the multiplicity is odd, it crosses through. However, in this lesson, we talked about what happens when you have larger multiplicities. And what we learned is when the multiplicity is even, it's going to bounce, but the larger the multiplicity is for an even number, it becomes more flat. But we learned that it's never exactly flat. It's just a very steep curve, okay? So this would be like a multiplicity of like 2, right? Because it bounces. This would be anything that's like bigger than 2. A good suggestion would be probably a multiplicity of 4. You can see that it's still curvy. It still appears to be curvy, but it becomes more flat. Similarly, for odd multiplicity, right? The same thing happens. The larger the odd number, the more flat it appears to be as it approaches the intercept. So with that being said, we're going to go through one example. So something that you would be expected to be able to do is not this question. This question, actually, I shouldn't say it like that. This question is going to be your asynchronous work. You're going to be able, or you should be able to, do this question by the end of this little video. This is the one that we're going to do. All right? So, just like always, we are going to graph this. To be able to graph this, you need a couple of things. You need to know end behavior, degree, leading coefficient, so on and so forth. The first thing that I can easily do, because this is in factored form, is find the zeros. And because all of these are just x plus or minus something, I know that this is x equals -8. This is going to be +4. This is going to be 0. And this is going to be -2. I also know that the multiplicities of each are easy to tell because the exponents tell you how many copies of your solutions do you have. So for -8, the multiplicity is 2. For 4, the multiplicity is 7. For 0, the multiplicity is 3. For -2, the multiplicity, be careful, even though there's nothing here, there's technically a 1 here. So it's multiplicity of 1. We also know, this color is bad, I should not have chosen that color. We also know, based on the multiplicity, we know the degree of the polynomial. We learned the rule that when you add up the multiplicity, it equals the degree. So 7, 8, 9, 10, 11, 12, 13, the degree is 13, which means that it's odd. We also know the leading coefficient. A very easy way to see this is ignore everything except for the first term in each factor. The leading coefficient for each of these individual factors is +1. So if you imagine multiplying this all out, it's positive times a positive times a positive times a positive. Regardless, it's going to be positive. Okay? Degree odd, leading coefficient positive means the following. My graph's end behavior is going to look like this. Graph my end behavior. Now I can plot my zeros. My zeros are -8, +4, 0, and -2. Now, for practice, what I like to do is I like to write out if it's going to bounce or cross. So for 2, it's even, it's going to bounce. 7, it's going to cross. Oh, this is a terrible color. Hold on one second. It's going to bounce. It's going to cross. It's going to cross. It's going to cross. Now all you got to do is just connect everything. So let's do it. The first one I have to approach is -8. -8 has a multiplicity of 2, and it's going to bounce. It's a low multiplicity, so I'm not going to make it too flat. So I'm going to make it go up and it's going to bounce, boom, and it goes up. And again, I'm doing this digitally, so it's way more complicated, but just make sure everything is a curve. Okay? The next multiplicity that I have here is -2. So I did this one. I'm done with this one. -2 is here. It's going to cross. Remember, when the multiplicity is 1, it's going to look linear. So it's going to go down. Obviously, it has to turn back, and it's going to go straight through here. Okay? I did that one. My next x-intercept is 0. We see that the multiplicity is 3, which means it's going to cut through it, but it's going to look like a cubic. So it's going to have that little curve. So it has to come back around, go around, and go like that. Do you see how is that little tiny curve? We got that. Now again, your turning points, like these like little humps, maybe different sizes, that's completely fine, so long as if the characteristic of the bouncing crossing is there. That's the most important part. All right, last but not least, now we have a multiplicity of 7. So if this was my multiplicity of 3, when I turn back around at some point, maybe I want to turn around here, I know that my multiplicity here has to be more flat. So I'm actually going to erase this a little bit. I'm going to make this a little bit more nice. So let's do something like this. Maybe it goes down like this, and it turns around. This is a multiplicity of 4, right? It's a little bit tight, but let's see. Again, like sometimes like you want to pre-draw it. So maybe it's a little bit more steeper. And you see how like I'm taking my time, I'm erasing, I'm trying to figure this out. So I know it has to be, appears to be flat. Of course, when we draw, it's going to be flat. It's going to look flat, but we just want to exaggerate it a little bit. So maybe it goes something like this. It's a lot easier when you try to pre-draw it. This definitely looks more flat than this, right? Because I literally have a straight line. And I just connect. My end behavior is correct. My zeros are correct. My multiplicity is correct. Now it's your turn. You're going to be doing something similar to this, only that one's going to focus more on even multiplicities, but it's the same idea. You have to be careful because depending on the multiplicity is going to depend on either if it bounces or crosses or how flat it's going to look like. If you have any questions, please reach out and have a great day. Bye, everyone.